So to kind of kick things off, I want to introduce Ramya Swaminathan, who's our guest interviewee today. She is the senior advisor and board member and former CEO of Malta. So we'll get into a little bit more from that in just a second. And then I just always love to kind of show this, and I'll bring up, I'll stop sharing here in a second, and then we can actually see your lovely face, Ramya. So perfect. So as mentioned, so it's my absolute pleasure to really introduce our incredible guest today. So not only is she a brilliant mind in the field of energy storage, but really kind of a leader and inspiration and a champion for diversity and women in the industry. So a little bit of background before we begin, but Ramya Swaminathan has more than 30 years experience in the energy industry with varied experience in building companies, technology commercializations, finance, capital markets, commodities, you name it, she's done it. She has successfully founded 2 companies and raised over $200 million in Topco capital from venture and PE funds, as well as strategic investors. Most recently, she actually led the spin out of Malta from Google X, raising more than $100 million across 3 funding rounds, establishing a global workforce and project pipeline, which we'll get into today. Close technical commercial partnerships with blue chip industrial companies like Siemens, Alfa Laval, Cox Group, and Proman. She has worked with some financial investors, world class like Breakthrough Energy, Google, Dustin Makovitz, and Chevron. And then also has worked on recruiting Malta's executive team and senior staff. Prior to this, she was involved in investment banking, where she managed $10 billion in financing across various kinds. Not only with all of the stuff she's doing, but she's also appointed as an advisor to the U.S. Department of Energy and the U.S. Department of Commerce, and has expertise in the policy, government, and both the U.S. and the EU. So first off, welcome, Ramya. Appreciate you being here today.
Thank you so much for having me, Dana. Very big shout out to the Volta Foundation team for all the work you've done in making this possible.
Well, perfect. Thank you. I always like to say we ask this in the networking, but we'll ask it as a group. My favorite question to ask is, before we begin, what's your state of charge? How are you feeling today?
Today, fully charged, ready to go. And
right.
I hope on behalf of the entire kind of storage industry, I hope that's our state of charge for 2025 and beyond.
Wonderful. Yeah, it's I think before everyone was joining, we were talking of like, it's sunny, you're in Boston, I'm in Detroit, Ashlyn is in New York. So at least on the East Coast in the colder areas, it's sunny and nice today. So I always love that too. That's helpful. Well, perfect. I know we kind of kicked things off, and we had a little bit of a discussion too, hopefully in the networking sessions and prior to us starting. But I think one of the big things, and for those that maybe have read up a little bit on Ramya's background, growing up, we'll say, in India and Philippines, and really transitioning whenever you came here to the U.S. for schooling. What kind of led you in your career? Kind of why energy storage? What from your maybe childhood or your passions kind of led you to kind of where you're at today?
Yeah, and I think that's such an important question for all of us to ask, right? Which is, what are our motivations in doing what we do? So for me, as you mentioned, I grew up in India and the Philippines. And in those years, I'm talking about the 1970s and the 1980s, while they were certainly electrified, the electrification was very fragile, right? So we experienced lots of bouts of not having stable, reliable electricity, and would have, rolling brownouts, blackouts. Certainly any extreme weather events would cause a disconnection, etc. And that wasn't true just for electricity. That was generally true for the provision of many infrastructure type services, right? Including water, etc. So for me, I've always been interested in the kind of stable, reliable, and affordable provision of utility services. Very much been a driving force and a through line in my career. So when I first started working, I was working in the financial services industry, financing infrastructure projects. So not limited to electricity. I certainly had a focus in electricity, but I also financed water and sewer, transportation projects like roadways, bridges, et cetera. And that was really a motivating factor for me, was looking back to an environment in which the provision of these public services was always a little iffy. And, financing them initially was very much where my interest was. Over time, I became interested in much more than just the financing aspects of it. And if you worked in financial services in 2008, it certainly felt like the world was ending. So I left with two colleagues from UBS. We co-founded a hydropower development company. So hopefully you can continue to see that through line. It was very much in clean energy production, focused on local generation in the areas that we had projects. And over time, we grew that business to be the leading platform of new hydropower on existing dams in the United States. The headline number there, I'm going to detour for just 1 second from batteries, but the headline number there still shocks me. There are 79,000 dams in the United States, and only 3% of them have power. And so the thesis of that company really was, certainly, there's quite a bit of action around dam removal to restore ecosystems. And even if you were to take down 10% of those dams, there's still an enormous amount of potential in terms of the power. And so if you have the dam, you may as well have the power. So we created a business focused on that thesis. Over time, and here you'll see the connection to batteries, we expanded the thesis to focus on pumped hydro storage, which is the oldest form. The oldest kind of battery is a water battery, right? Essentially. And for those of you who are not familiar with pumped hydropower storage, basically you have two reservoirs at two different elevations. And what you do is, when electricity is very plentiful, you pump the water up to the top level reservoir, to the higher reservoir. And when you need that power, you run it back downstream through a generator so that you can generate electricity. And actually, the first pumped hydro storage projects grew up around nuclear plants. And nuclear plants really have very stable generation, right? They really cannot load follow. So at times where you had excess nuclear power, the pumped hydro station provided the storage for that power. That was the history of that particular technology. So I worked on that, and in 2018, a wonderful technology that had been incubated at Google, at X, at the Moonshot Factory, and it was called Project Malta at the time, was looking for to spin out from Google, and they recruited me to come in and build the business plan and put the company together. And that's what I did. I led the spin out of Malta from Google. And the very first thing the folks at Google told me when I met them, and it still makes me smile, is think about Malta just like pumped hydro, but without the hydro. And the reason they say that is that Malta is a pumped heat electricity storage system. So instead of pumping water, you're pumping heat from a low temperature reservoir to a high temperature reservoir. So very similar in terms of the value it provides on the grid. We'll talk about that a little bit later. But so I was essentially the founder and the CEO of that company, having led the spin out for 6 years. And I just stepped down towards the end of 2024 and remain on the board and a senior advisor to the company.
Wow, that is pretty impressive, especially for kind of that transition. And I could definitely speak for a lot of us on the call today. It's that's never knew that the fact that only 3% of the dams of the we'll say less than 80,000 have power. Like, that is just shocking for me.
It's
So
yeah.
If that question's ever asked on Jeopardy or something, now we can successfully answer that.
You
But
can be a
no,
lifeline for a friend. Exactly.
yes, I love that. But that's perfect. I know, obviously, as you mentioned, kind of now as the board member and advisor, but you really helped kind of craft and build Malta from the ground up. I think the fact that leading the spin out, helping raise, hundreds of millions of dollars over the last several years, a lot has gone on, and I'd love to know kind of what's your defining moments? Like, if you look back at time, what's maybe the defining time that you've had so far at Malta?
Yeah. Anyone who has worked at a startup and a scale up will recognize the truth of what I'm about to say, which is sometimes it feels like every day is a defining moment, because you come in and, I often in this kind of environment, I talk about the fact that we have sort of three immaturities to deal with as a startup, right? You have an immature product, you're building the product, right? And the technology. Most of the time you have an immature market. So you're also dealing with bringing the customers along, right? And in the case of electricity, it's not just the customers, it's the entire regulatory system that enables the purchase and sale of electricity. And then you have an immature company, right? You're also building the company. So you've really got to attend to all three of these by having a very clear sense. And that sense can change over time, but at any given time, you have to have a clear sense of where you're going, a North Star, a guiding vision. And for Malta, the guiding vision for me personally and for the company was that partnership was in the DNA of the company from its birth. So the defining characteristic of Malta's technology is that almost all the various components are really used at scale in power plants and are fully commercial, and they've been used for decades at scale. The one part that is a absolutely new development is really the scale heat pump on the charge side, the charge compression side. But basically, the fork in the road from the beginning days was Malta as a company going to develop all its own technology, or was it really going to partner for the development or co-development of these pieces, industrial pieces that were available in the market? Now, when I say that these are components that are in use in power plants globally, I want to just hasten so you understand the background. They're not available from a catalog. Many of the pieces are custom built, custom designed for this purpose, but the ecosystem, the expertise, the manufacturing capacity, it's all very deep, and in many cases has existed for more than 100 years. And so a fork in the road, and we made a very sharp and very definitive turn towards partnership. So partnership has been in Malta's DNA from day one. We have large kind of global industrial blue chip companies at the table helping to develop and co-develop our technology. Siemens Energy developing the turbo machinery side, Alfa Laval developing the heat exchanger side. We've partnered with some of the world's leading EPCs to do the engineering design, et cetera. So it's interesting, Dana, to ask the question, like, what's the defining moment? It's very hard for me to isolate one, but I would say that is really a foundational principle for the company.
Yeah, and it's interesting you mentioned that too, because I've also been in, we'll say, startups and government and all over, and it really is, it's the partnerships. And I think within partnerships you kind of find that, like, the passion, right? Because
Yeah.
every organization has a different kind of technology that they want to feature. And actually it was kind of interesting, and I'm interested in learning more about it. But as we were kind of diving in a little bit, a lot came up about the steam salt battery that
Mhm.
Malta's working on. So I'm someone without that much of a technical background, but it was super interesting. So what can you kind of tell us more about the steam salt and then the other technology that Malta's been working on?
Yeah. So let me tell you a little, let me zoom out for a second before diving into the technology itself. So what are the reasons that we need to have long duration storage? So this is obviously, this entire group is focused on batteries, and there's been a lot of technological advancement in the electrochemical side, particularly with lithium ion providing electrochemical battery solutions for particularly short duration applications. And when you start getting into durations of above 8 hours, right? What is the reason for that? And I want to just kind of start high level, right? Why do we need long duration electricity storage? And I think that as we kind of stand at this moment, we really see one kind of overriding trend in electricity markets that is driving this relationship, which is that wind and solar, primarily, renewables generally, are the cheapest form of generation globally, right? Prices of renewables are asymptoting towards zero. You can buy solar for $10 the megawatt hour in certain places. And so that's a remarkable fact, right? And that has really happened over 20 years, and it's accelerated significantly in the last five, that pricing trend. And so, okay, if that's true, and now wind and solar are the cheapest form of generation, well, why don't we just build more and more and more wind and solar? Well, the answer to that is that you can't. You cannot build a grid, a full grid that provides 24/7 reliable, resilient power, 24/7 with intermittent sources of power. So two reasons for this. One is very obvious, and that's the one I just said, which is intermittency. And that's very evident to see if you think about solar, right? And let's say you're adding more and more and more solar, you're stacking more and more power in the same hours of the day. And so at night, in the evening hours, particularly during the evening peaks, right, when the sun is starting to set and solar generation is going down, you actually are struggling to provide power, meet the load, at that time. So intermittency is a reason that you need long duration electricity storage, which is you need to time shift that extra power you get during the day in the case of solar, or in high wind times in the case of wind, and move it to a time where that power is not available. The second reason is actually a little bit less visible. It's a little more esoteric and technical, so I'll keep it simple, which is that all grids run on a particular frequency. And to maintain, in the United States, it's 60 hertz, and a lot of the rest of the world, it's 50 hertz. And to maintain that frequency, maintain the reliability on the grid, we rely on rotational inertia, essentially large rotating equipment, which is turbo machinery. And we rely on that to essentially provide that stability on the grid. And as we add more and more kinds of generation that don't have inertia associated with them, and we take offline coal and gas and nuclear, all the traditional forms of rotational inertia, actually grids become more unstable. And so that's a place also where if you're providing storage, energy storage, which addresses the intermittency, but adds inertia in the case of Malta, where we have actual large rotating equipment in the form of turbo machinery, that is a way that you can maintain the reliability of the grid. So having kind of set up the argument for why this is a pain point, right? We're adding more intermittency, we're adding more inverter-based resources, which means that we're kind of edging towards a crisis of reliability. The technology on the salt steam battery really enables us to shift power and then provide reliability to the grid. And so the technology works, essentially, it's a heat pump and a heat engine. And the heat pump side essentially takes electricity from any source. It's agnostic. It's just excess electricity. It goes through a charge compressor. The steam is compressed, and it's able to then heat up salt. And so it turns out, and we know this based now on more than a decade of experience in the concentrated solar industry, that salt is a terrific medium of storage. When you heat salt above 270 degrees C, it becomes a liquid. You can pump it. It's very stable. It holds the heat very well and loses less than a percentage point of its heat every day. And so you can essentially take the heat, put it to heat molten salt, sit there in a state of charge until that electricity is needed back on the grid. It goes through a discharge cycle, which is a standard steam cycle discharge cycle, just like you would have in any steam plant, like a coal plant or anything else. And so the generation side of the Malta cycle is completely standard. And so that speaks to actually something that's pretty important, which is the ability of this technology to essentially integrate into existing steam plants of all kinds. They can be generation plants, they can be other forms of steam. And so the choice of working fluid is really important for that. So that's a little bit, I'll stop there. I certainly don't want to make this an advertisement for Malta, although I truly think it's a terrific technology. I really want to get back, Dana, to answer the questions that you want to address. But I wanted to just point out that, the needs for us to kind of move from our old grid environment where we really had a unidirectional grid with large generation plants that largely burned certain kinds of fuel. The fuel was separate and typically had a different transportation system, like coal came in on trains, water came in on the river, et cetera. Now we're talking about fuel as electricity. So the system is becoming bidirectional. There's a lot more distributed resources, which means that the electricity is moving in all different directions. We're moving to a completely different future grid environment. And so we need technological solutions to enable that transition. And it's a complex transition. And so that's really the pain that Malta is trying to solve.
That's just, I mean, it's wonderful to even just think of like how the technology is kind of coming about. And I think we've chatted before too, between grid and solar. We keep saying it's going to be the best decade. I think all of this
I
is
agree.
really helping to kind of narrow down that point. Well, perfect. I know, and I appreciate the technology background. I mean, this is a Women in Batteries, and we do like to love to talk tech.
Yeah.
I think one of the things that I actually would love to know, and I think some of the others, a lot of, especially the women and allies on here, where maybe engineers tend to be like entrepreneurial mindset at heart. You really have successfully founded two companies. But really, as a female founder, I would love to kind of learn more about, what the adversity that you've had to come maybe overcome, some advice for those that are on here that are maybe thinking of like they want to take that step to maybe be a startup or start
Mhm.
their own company. So what advice do you have from your own experiences being a female founder? Do you maybe have for us?
Well, I want to share something with all of you, which is the truth is that I have no educational background for really anything I've done for the last 15, 20 years. So the message to you, right? So I was an anthropology student as an undergrad, and my graduate degree is in public policy. And so one message I have, and it's only one message, which is don't be limited by what you think you're prepared to do. Because in the future, all of us are going to be working at jobs that probably haven't even been invented yet, right? So as long as you like to learn, as long as as long as you've learned to learn, don't let what has happened in the past really define what it is that you can do in the future. And I'm an absolute example of that. And I just wanted to share that with all of you. Um, I think I sort of have my mind goes in two different directions in answer to your question, Dana. One is that in the kind of battery world, in the renewable energy world, in the clean tech world, the climate tech world, however you want to cut this, right? I think we have a mental image that really you need to be a super smart engineer to participate in that world. And of course, you need to be super smart. There's no question. Every one of you is really, of that caliber. But I want to just remind all of you and make sure that all of us internalize the message that we need everything in these companies and in this industry, right? We need lawyers, we need marketing people, we need people who understand policy and government, we need regulatory people, we need commercialization people, we need salespeople, we need operations folks, we need people who know how to build and develop projects and then finance them. We need everything. So all the skill sets that people around the table here have are in some way relevant to the battery world. And I want to make sure that that is also a message that all of you hear loud and clear. So it very much in the spirit of what I just said, right? We shouldn't think that the future it only requires one kind of person. It requires all kinds of people. And so you've got a place at the table. In terms of your other question, being a female founder, et cetera, I mean, I think the truth is that however you kind of segment the various roles that you could count me as an example of, I'm certainly a female founder. I'm, venture backed. I've been in the energy industry for a long time. All of those, unfortunately, the statistics are pretty poor. I've read somewhere that I think 2% of venture funding goes to female founders. Female-led companies. And certainly the energy industry has been for a long time extremely male-dominated, et cetera. So I think that, change comes because we're going to make that change. And so again, for all women on the call, all allies on the call, I think the message is just, we have a place at the table. Let's move ahead and, participate. That's how we're going to make the change. And again, there's a place at a table at this table for people with all kinds of skills, irrespective of what it is that you've done in the past. And so that's what I would say. My big message to all of you is participate. Let's do it.
Yeah, I love that. Like I feel like there's a bunch of people now that are clapping that I can see, which is great. And Darlene on the call pretty much said that the message of don't let what's happened in your past define you for your future. I think that's, entirely accurate. And I think that that's one of the key messages that, with us within Women and Allies, we can kind of help uplift each other
Yeah.
and really empower each other. And so I know before we we'll kind of open it up here to the Q&A for the rest of the group in a minute or two, but would love to kind of know, based on that, really how are you
Yeah.
empowering other women in science, tech, batteries? Would love to learn more about, some of the work
Yeah.
you're doing with DOE and the U.S. Department of Commerce.
Yeah.
But really, what are you doing to help empower women? But also, how could we help empower each other?
Absolutely, and a great question. So, two efforts that are really dear to my heart. I am a C3E ambassador with the Department of Energy. C3E is Clean Energy Education and Empowerment, and it's a group of people appointed by the Secretary of Energy, all women who are basically we have only one mission, and that mission is to promote the participation and success of women in clean energy activities and careers across all different kinds of sectors, ranging from academics to research to commercial to innovation to technology commercialization to project development to everything. So a group of very senior women, myself included, in the energy industry, we promote women's participation in these sectors. There is a job board. We certainly, we talk the talk. We try to be ambassadors, and that's why our title is ambassadors. But we also try to be very pragmatic, and so we have a job board. You can basically, I think, most of the ambassadors would say the same. You can approach any of the C3 ambassadors. We take the mantle of promoting women in this industry extremely seriously. We try to mentor women, help them, connect with them on LinkedIn, pass on opportunities that we see. We hold events, we host events. So if you're interested, please look up the C3E program on the Department of Education website, and you can find practical resources there. Another extremely practical organization that is very close to my heart is Women in Energy, the WEN Network. I've been part of the Boston chapter, and it has a terrific leadership team. And they too are not only sort of talking the talk in terms of representing women, but very practically are on the ground helping folks with, days where they'll take headshots, for posting on your LinkedIn. They'll help help write resumes, help practice interviews, provide connections, networking, all of that. And in your city, I'm sure there will be a WEN to join. So I think really the point for all of us. So those are two very specific things and specific causes that as I mentioned, are dear to my heart. But I think, again, for all of us together, I think the goal is, where and when you see opportunities, let's make space at the table and lend and reach out a hand and pull people to the table. That's the goal. And everybody can do that. Whatever level, whatever organization, and whatever sector you're in, we can all do that, and we should do that.
Yeah, I couldn't agree more. I think there's been some good questions that popped in, and I popped even the Women's Energy Network URL in the chat
Mhm.
as well, so in case anyone would want to take a look. And I think it's interesting too in what you say. I mean, I think the let's make space at the table kind of reminds me of the the Wicked Ariana Grande, like making space, holding space. It's very similar, but for women in tech and science, I think that's exactly what we should be doing. No, perfect. I want to make sure we give time for the audience to ask some questions. So for those that would want to come on, camera on, you could ask a question. You could simply do the Zoom raise your hand, and we'll call you over or call you for live. Otherwise, we do have a couple questions in the chat that we'll get to. So I was going to say whoever wants to be the first to maybe ask a question live. Otherwise, we'll pop over to the chat. So I'll give everyone a second. All right. Okay, so we'll say this is maybe more of on the technology side, but a question came in from Avantika. So compared to the pump hydro storage, how is Malta's technology better as a long duration storage? Was it difficult to market maybe Malta technology to developers or utilities? With the only 3% of the 79,000 dams converted in the US, it's easy to maybe convert them, then invest in a tech project. Can you just kind of go more into more of that?
Yeah. So let me first give you a quick comparison between pumped hydro storage and Malta's technology, and then let me talk a little bit about some of the barriers, which I think is what the question is getting at. So the thing about pumped hydro storage is that it's an absolutely terrific technology that is difficult to beat in terms of cost point, right? So the thing is, however, you can't build pumped hydro storage everywhere because it requires very specific geological features. You need two reservoirs that are separated by a lot of elevation, right? So if you can do that, it is a great technology. Now, pumped hydro storage projects tend to be extremely large, and so there's an upfront capex that is very high. But over time, I think on a lifetime cost basis, it's very difficult to compete with pumped hydro storage. It's a terrific technology. That said, I think there's been more understanding of the environmental impacts of pumped hydro storage. You've probably heard some of the stories of, flooding major reservoirs. They, essentially build a dam and flood a reservoir. There are some environmental impacts. There have been dislocation of people, et cetera. So certainly factors to consider. Now, in terms of comparing that to Malta, Malta's real kind of strength is scalability. It can scale very well, but it's very flexibly sitable. So Malta needs no special geological features. It doesn't need any caverns. There's no storage underground. You can site one essentially anywhere. And so that is a major plus point relative to pumped hydro storage. And part of, for me personally, the motivating force behind moving to Malta and helping create the company was really that I thought pumped hydro storage was very necessary, needed. I could see the pain caused by lack of storage, but pumped hydro storage is not going to be the solution that provides for maximum flexibility in terms of siting moving forward. Now, in terms of the barriers, right, there are many different kind of barriers that you can think about when commercializing a new technology. Some of them just have to do with the newness of the technology, right? You've got to build prototypes. Electricity customers are extremely risk averse, and rightly so, right? You and I both expect that 100% of the time when we flip the light switch, that we do so in complete safety, that the electricity system is very safe, it's reliable. We demand all these things. And so in that extremely risk averse and highly regulated environment, it can be difficult to persuade people to adopt new technologies. That's not limited to Malta. That's generally true in this industry. So that's definitely true that commercializing new technology, particularly large scale, hard technology, takes a long time. It takes a lot of money. It takes very smart people, but it also takes the whole ecosystem. It takes the regulators, the policymakers, the customers, the utilities to really move towards adoption of new technologies. And so that's an important thing. Whereas pumped hydro storage is a technology that's 100 years old.
Perfect. And I know, thank you for that. I think we'll say maybe there was one follow-up or it's a technical question, and then we'll get Connie. I see you'll be up next. But someone in the chat asked, what is the round trip efficiency for Malta?
Yeah. Entitlement efficiency is between 65 and 70%. So pretty good efficiency.
Perfect. Yeah. All right. That was a good, quick answer. I love it. Perfect. I know, Connie, I see you have a question. Feel free to come on and ask away.
Sure. Thank you for sharing an incredible story, and wonderful to see women having such levels of success in this space, which is not common, as you pointed out. I'm curious, one of the things that I find interesting in the space is when we look at potential investors, it seems that everybody shows up at like Series A, Series B, and so forth. But with hardware, of course, you're your expenses as a startup and a scale up are very high. But it seems like there's not a lot of resources available for those companies in the earlier stages. So, is that something I'm imagining, or is that maybe the case more specifically in Canada where I am? And if it is very much real, how do we get around some of that so we stop losing so many earlier stage companies?
Yeah, I think the financing of what I'm going to call hard tech, as you point out in your question, it's really interesting, right? Because in many ways, hard tech has, if you look at all the characteristics of hard technology, it has all kind of the qualities of good investments in negative, right? So what is a good investment, right? Like in an ideal world, right? You'd want to spend a little bit of money to build something, and then in an ideal world, you would go ahead and test it and it would work, or maybe not work, in which case, if it doesn't work, you lose that little bit of money you put into developing something. But ideally it would work, or if it kind of works and not really works, you could put a patch later on, send out a patch to the system. And you can acquire a million customers, 2 million customers, a billion customers quickly, right? These are the ideal characteristics of a great investment. And if you look at hard tech, as you pointed out in your question, like it has all the opposite characteristics, right? It's very expensive. It takes a long time. A lot of times we don't really know if it works or not until you get to the proof point. A lot of times scale technologies struggle even more because they're not modular. You can't just build a little one and then build multiple little ones to make a big one, right? And so there's not only the question of kind of the first lab scale and then maybe the demo scale, the pilot scale working, then what are the risks in scaling that up? Right. And in the electricity industry, ultimately, like our goal is hundreds of megawatts, right? So you're not going to get very far by doing it, a few kilowatts at a time or anything like that, right? So these are all difficult. So I've not answered your question. I've only underlined your question. I've only said, I agree with your question. It is a great question. So what we see, what I've seen in my experience is a little bit different than what you've described. So traditionally, I think there's a reasonable amount of money for the extremely early stage for kind of the lab work. Much of it is government. Like there are a lot of government instruments, including ARPA-E and other things that really have funded, and the national labs have done yeoman's work in doing the primary research that has enabled a lot of these technologies. Malta's technology, for example, came out of Stanford. The original originator, the technology was the brainchild of a professor at Stanford. So our research universities incubate a lot of these technologies. And so that's where they are capitalized. At the opposite end of the spectrum, like once a technology has been fully commercialized, de-risked, there is a very large and liquid project finance market to build projects on scale. Where I think there's a real white space is in the middle. It's often called the valley of death. You can hear that terminology in the venture space. And it's really kind of centered around when you go from pilot scale to scale up, right? How do you scale up with all the risks that are involved in a first of a kind demonstration? And I think there's a lot of need for not only funding, like capital is one thing, but also for instruments that, for example, enable performance guarantees, right? When you sell a piece of equipment or a power plant to a customer, or the output of a power plant, they rightly say, well, what happens if you don't perform? Right? I'm basing an entire plan on the fact that you're going to give me all this stuff. If you don't perform, you're going to pay me. That's called liquidated damages. And for startups, for small companies that are not well capitalized, it's very difficult to provide those performance guarantees. And so instruments that help commercialize, make these projects bankable, I think there's a huge white space, and that needs a lot of attention.
Great
Perfect.
answer. And I have to say, I agree with your assessment. I think the earliest stages, there is some money there, but as soon as you start to be in a space where you're needing to acquire production equipment and
Yes.
hit the ground running, now all of a sudden the numbers get a lot harder to manage.
Absolutely.
Unfortunately, I think in
Real
Canada,
stuff is hard to make.
stuff.
Right.
Yeah.
Real stuff is hard to make and it's expensive.
Yeah. Appreciate that. Thank you.
Perfect. I know we're at time. One more question came in. So Ramya, do you have a few minutes to maybe answer this last question? Okay. So Darlene asked, as someone with a PhD in communications and research, with a background in public relations, teaching and measuring organizational performance. By the way, great. My background's in PR too, so love that, Darlene. What type of opportunities are available in this industry? So I know you talked a little bit about, everyone kind of has a seat at the table, from operations to marketing and sales. But maybe kind of what have you seen for opportunities, or maybe where do you think a lot of those opportunities lie, and especially the future of BESS and grid and hydro?
Yeah, absolutely. I really think there's a huge opportunity for people in the communications and marketing spaces, because I think a lot of this is about storytelling, right? In the end, when you're, yes, there's a core technology. Of course, you have to have a core technology in a product. I'm not suggesting that, the story overrides that. What I'm saying is you have this, but then there's an extremely complex landscape. You're telling the story of why that technology matters to investors. You're telling that story to customers to say, here's your pain. I know what you're dealing with, and here's how I solve your pain. You're telling that story overall in general to raise consciousness about the need for these kinds of technologies. And so, Darlene, I think with your background, any kind of startup scale up, particularly at the scale up stage, would be lucky to have an expert at messaging what it is that they're doing and how they're making a difference, an impact, both for investors and for their customers.
Wonderful. I completely agree. And actually, one of the interesting things, maybe it's a little shout out to our upcoming Women in Batteries conference, which will be at the end of July at Stanford, more coming soon. We're actually going to be doing kind of a disciplines in batteries or disciplines in tech panel. So, looking for someone within marketing or a CFO or operations to really kind of highlight all of the different functions and areas within the battery industry. So more to come, but great question, Darlene.
Thank you.
Well, perfect. Well, I know we are at time. So first and foremost, Ramya, thank you so much for joining today. It was just, I think, very inspirational and insightful to kind of hear from where you started to where you're at now, and all the wonderful things you've been doing with Malta. I think, I could probably speak for many of the women and allies on here. It was just a pleasure to kind of hear you speak today. And for those that are interested, we will be posting this kind of as a catch the replay or watch on demand afterwards in the coming days. So we'll send out more information about that. One other thing, and we always like to do just some quick announcements. So I know Ashlyn in our group is going to be posting some upcoming events within Volta Foundation, or some key links. They're also available in the resources tab on Zoom. So just a quick few things. So this Saturday, we will actually be launching the PDF download for our battery reports. So highly anticipated. So make sure that you to sign up to receive a copy in advance from when we post it on the 1st. So we'll post the link in the chat there to sign up. A few other things. So for International Women's Day, Take Charge, which is part of Strata Group, which is one of our member companies, is hosting a gender diversity panel. So we'll pop the link in the chat if you do want to register and sign up for that. We'll also be sending out some more information for those that would like to. There were a few questions about careers. So we do have a careers opportunity in the battery industry panel coming up on March 11th, as well as the anticipated battery career fair that will be on April 3rd. So we'll pop those in, make sure you tune in. And then lastly, for those that are going to be at the IBSE conference in Orlando, Volta will be there. We're hosting one of our famous battery social networking events. So grab your ticket. It's almost sold out. So we want to make sure that people have the chance to attend. So all the links will be in there. We'll send out more. But I think first and foremost, thank you again for attending the Women in Batteries interview series. Ramya, thank you again, I think, for just sharing your wisdom and experience with us. And yeah, that was all that we have for today. So we'll share out that Women in Batteries interview on YouTube in the coming days. So be lookout for a catch replay. But otherwise, just want to say thank you again and enjoy the rest of your day.